I'm Chris Westerlund, as I don't think I actually introduced myself earlier. I'm the director of the makeLab. I also am an architectural designer at TDG Architects.
My name is Pandosh Gachi. I'm the owner of Cold Design Studio, which I started right at the break of the pandemic. I used to work with a lot of other informers, which are in the audience today and probably like online, kind of following this along. The idea was that we kind of have these moments of like catching up with each other after kind of going on and doing our own stuff. And today is like a great time to kind of meet everybody and to get introduction to what you guys do and what we do as well. Yeah.
So today we're going to talk about our companies individually and how we're collaborating and what we kind of see the future of our companies, how they're operating.
Yeah.
So I'm going to talk about the makeLab's kind of a complex story. Like when someone asks me, what is it? I kind of have to like share some slides and some context to it. So I'm going to quickly kind of go through that, like the origins of the makeLab, what it was, and now what it is. So the makeLab was founded by Jim Stevens back in 2010 when he was a professor at Lawrence Tech. I believe it was founded outside of the university at first, but then was brought into the university by the administration at that time, where it spent quite a few years there acting as a place of research of digital fabrication tools, and then also offering services to sponsors outside the university. So kind of acting as its own company, operating in kind of small scale projects that students will be able to fabricate and install on their own. And so what the makeLab did in that period, it created some tools. So tools was a key portion of the makeLab, with the idea of creating digital fabrication tools that you could maybe take all over the world and operate these ideas on. So that image on the right there is a CNC that fits inside of a suitcase that you can use as a carry-on on an airplane. So if you have the idea of, we can design things digitally, and then if we give this tool to someone anywhere in the world that has power and something to operate it with, you could build whatever you kind of need and use this tool to fabricate. Alongside that was some experimental tools. So on the left side there is a concrete printer, Delta printer, creating similar shapes that you see here today. Alongside that was workshops. So traveling to Albania, traveling to India and China to spread these kind of ideas of how we operate using digital fabrication. So on the left side there is some completely, or what is it? The compressive structures. They're utilizing a paper model there, but you could do compressive structures with brick. And then on the right side there is CNC and some brick to create some interesting patterns. Some additional projects that were kind of outside the university. So like I mentioned, students working on projects as if they were in a firm. And then on the right side, projects that are built literally inside the university, playing with ideas. It's a waffle CNC plywood with concrete pillows as the seating arrangement there.
What's interesting about these projects is that they actually got a lot of the students, as you saw some of the names. I'm going to go back here once, like De Kruiger, Burr, Haddad, Kloppenberg, like these are all my colleagues from 2010. And what we really got the first taste of like what it would be like to produce stuff that is larger and kind of like outside of your own capacity using traditional tools. So it was like a very eye-opening experience, because ultimately we decided to take on risk to create, like to build a CNC machine, to build all these tools, to create projects that sort of like had to meet a very impossible goal of like cheap, fast, good, the triangle, and we pick 2 out of the 3. That's kind of what you get usually in the industry. So we were trying to like mitigate that difference by trying to maybe do fast and good, but can we achieve it to be cheap as well, or to achieve a type of cost that would be broader in exposure, and to be able to be used and kind of like taken advantage of, but all kinds of clients, people, etc., without having to have the capital that is required usually to do digital fabricated stuff. Some of like my own background here is that I worked with one of the other partners from makeLab to design and build this project, which resides currently at the Welcome Center and at Lawrence Tech. And some of the things about this project was that, as you can see in half of this image, there was like the space, got a lot of light, had a lot of these architectural components kind of breaking the hot sun, but not necessarily like really helping with the space. So what we decided to do was to create a baffle system that kind of responded to the conditions. And we used a lot of like analysis tools at the time. This was 2010, so this was like the early years of Grasshopper, but ultimately Ladybug, which we can see like these two logos on the side, was like it's a plugin for a plugin for Rhino, which is the 3D model, and to export these images of so many times a day for how many months, to create this sort of a map and matrix of all of the shadow and light patterns that you could see in the space based on the location of those steel beams, etc. So as you can see, like some of those like white spots are brighter because they happen to be in the summer, and then some other ones are actually in, like in the winter. So you see a variation of that gradient. Once you actually blend in all of those together, you'll get something that has a lot of gradient variation within that, the image itself, which then we use to translate. We kind of like overlaid everything together over that space. And we created this like this lighting analysis compiled year, which you see here in the middle. And through Rhino's, scripting and commands, we actually made a height field out of that. And you can see sort of like right here as it kind of hovers over the space where most of the light happens. Some of those curvatures, that angles, etc., that you're seeing the differences in the topography, and they correspond with these like, the structure that's above. It's creating that gradual change when we see that the gradient from all those compiled images. So ultimately, this is Home Depot. I like to point that out. We build a lot of jigs and stuff with that. My partner here, Steve Kruzma, is actually worked for Vogue Furniture, which is a really good, company making really high-end products for a while. And now he's a photographer, but ultimately he had his origins with me in the makeLab making these things. And he's also a photographer for Lawrence Tech and does a lot of like cool stuff too on his own. I would like to point out that the height field that you see here is that 3D image that we generated to then, slice up into like these baffles that were cut up to pieces and put together. And all of this was assembled within the hallways of Lawrence Tech University, including the painting. Probably doesn't happen anymore than today. So like, I like to pass this on.
So those are some of the projects that the students like Foundation were working on at the time. And then a lot of that knowledge was compiled as research into a book by Jim Stevens and Ralph Nelson, along with tons of research and projects by the students. And then there was also a heavy research component with contributing to various PhDs and different side publications like that we're showing here, some clay 3D printing. And then what happened in 2020, Jim left the university to go work elsewhere, and the college decided that the makeLab was kind of done and would leave the college. And I proposed the idea of kind of taking over the makeLab and moving it outside of the college, which Jim was very supportive of. And we transitioned it to operate as a nonprofit so that there could be a board of makeLab alumni, such as Pandush, to oversee that the makeLab is still completing its mission of operating kind of under this digital fabrication and supporting students and professionals in research. And so that is what we're continuing to do. So these are some examples of some projects. On the left there is Shinshin and Radish, which this is at a school in Detroit, some shelving fixtures. In the middle is an art installation at MoCAD by Aaron Jones. And then on the right is one of our own projects that I'll dig into in a little bit. And we're not operating workshops how we were before. We were traveling and kind of doing a traditional kind of classroom, but we're working with people who maybe don't have the knowledge and are approaching us and learning how to make. So on the left is a concrete chair it was designed by Sam April, who he just works at StockX. He doesn't really have any background in design or architecture or anything like that. And that project might not look like a digital fabrication project, but to make it as simple as it is and it looks there, we utilize 3D printing to make jigs for the concrete. We utilize some CNC to create jigs for those pipes there. And then on the right side is a project by Luke Blair, who does have architectural background, but didn't have the knowledge of operating a CNC and kind of actually fabricating something. So we were able to provide that service for him, but also teach him how to do these types of things. And then finally, we're still doing research just within our own ideas that aren't necessarily funded projects or projects for others. So the left side is more the computation design things. We're working with random numbers and some Python scripts and Rhino. And then more on the fabrication side, on that right side image is some rockite cast in water soluble 3D printed plastic. So plastic that you print, pour the concrete, and then the plastic just dissolves away because the water is making it disappear. And so one project I wanted to talk about was that growth project. And some of the projects I like to operate on that are kind of internal with the makeLab are creating objects and shapes and things that are really hard to do without digital fabrication. So the script or the image you're seeing on the left there was generated with a script in Grasshopper using Kangaroo. And all it's doing is it's taking that initial kind of oval shape you see, it's dividing it into around 50 segments, and then it's programmed to say, make the curves in between these segments as long as they can be without overlapping other segments. And then it's increasing that intensity over 50 times, kind of, if you can imagine it, layering on top of each other. And then I've created a box to kind of contain it so that it fully fills that box. And what you end up getting is something that looks like cell growth or organic growth, because that is how cells grow, right? They're competing with each other to just make circles and kind of go. And so when I play with these type of ideas, then it's like, well, now what do I do with them? Like, how do we actually make this? And to make a shape like this, it's kind of simple just to 3D print it, which I have a little version of it here, just to experiment with it. But then to go beyond this now, to capture an opportunity where I can do an installation with this or make this as a different human scale, like a table scale. And that's what ended up happening is we ended up getting kind of a stipend to create this structure about the table scale, about 4 feet high, and have it as an installation at a college. So on that left side there, what we ended up doing with this one is because you could 3D print it at that scale if you have a really big 3D printer, right? It's kind of costly. You could try to make it out of some other materials, but what I ended up doing was creating layers of plywood so that this could be CNC'd, and then all of these layers could be stacked on top of each other to create a somewhat abstract version of this shape, but still read as it can be. So on the left side, there are all of the cuts out for this, all of the layers stacked on top of each other to show just how complex it was. And then these 3 here are showing the different sizes at the different heights that it was. And then there's dowel rods, poles in the middle, so that all you have to do is cut these pieces out and then stack them on top of each other. And so this is what it ended up looking like, where the top piece, you don't see the structure within there, but it just looks like as it's growing out of this base. And really the stacking of the plywood kind of makes it even more interesting, where this image on the right side might not be, it would be a bit, the smoothness of this would kind of take away from the detail of just how different each layer, each piece is.
Yeah, this is an interesting project that we were not involved in, but other members of the makeLab actually had to fabricate, working with other architectural firms, and you can say Merge Architects in Yakima. And basically, I think it's the Beaumont Clinic, and they needed to cover these walls in a certain way. And what I wanted to delve into this was this little video that kind of highlights how something like this could be generated that would go beyond the Photoshop, work that we see with halftoning or trying to make an image sampler or something. These are all words that I'm using that have to do with digital fabrication as well, because people usually use those to laser cut, images that have certain pattern to them, they're generated. But in this case, we actually can control the actual depth of, that image a little bit, the threshold of the black and whites that you can actually get out of this, and how that relates to the thickness of the carve that you can make with the CNC. Basically, you control everything, all you need is an image to kind of, feed into the script, and then you kind of have a little control of how you want those details to be generated. In this case, it's horizontal lines, but as you saw in the project before, please. It's vertical, and we get a lot of questions about how something like this can be fabricated. And most of the time people think it's vertical strips that need to be individually, mounted and kind of fastened to the wall. But ultimately this can be done with maple plywood or Baltic birch. And we create this pattern that looks super complex, but between the two of us can handle in a really quick, short amount of time at, limited cost, basically. And can I continue further? So this is my company that I started right at the end of 2020. And this came out of like a lot of self-reflection about what I really wanted to do with my life after having some health issues, and I wanted to get out of the architectural world. But here I am back in, like architecture never leaves you, apparently. So I am an architect by trade. I'm licensed in the state of Michigan. I do work in architecture still, and I find it to be a very reliable source of income. But at the same time, I've started to incorporate my philosophy as an architect into making products and making things that are of a certain quality that also derive the name of cult. Like, I think it's kind of like a scary name, and people think of cult as like an actual cult where people do really mean things and kind of control people. But in this case, it relates to culture. It has the idea, it embodies the idea that everything that I do comes from like an origin in history, a piece of theory, a piece of an idea maybe from the past that kind of can be reinterpreted using digital fabrication and tools of today. I personally started building sort of an armory of like tools, and I think this is the thing about architecture. It kind of opens up possibilities of scale when you start to build like really small things and design small things, and you really start to design really big things when you work in architecture. So I kind of wanted to limit myself on that a little bit. And so I live with it's 2 humans, 1 dog, and 2 cats, and they're the supers in my house because they tell me immediately, when they're hungry and they need it now. So it's like having a really angry landlord, basically. And I started to make these things kind of that try to hide a little bit in the background the structural components or the structural integrity of something. If I build a product, it had to be thin, it had to be elegant, and it had to hide much of the stuff that makes it stable and sturdy. All of the stuff that I want to build comes from like a background of, trying to conserve, trying to recycle and upcycle materials. And that kind of makes its way in my projects. And in this case, like I actually made these like the series of tables that had a topography kind of carved underside, underbelly, which kind of got thicker towards the center and kind of thinned out all towards the edges. And that idea was to kind of embed that sturdiness into the core of the table or the conference table while using very minimalist, components. So in this case, is like 3 objects, and actually there is a skirt here that is non-structural that you can see, but ultimately that covers, there's like electrical equipment embedded in the table that we needed to hide that kind of went beyond the thickness of the table. And ultimately that kind of got me into thinking about this thing of culture, which I started studying a little bit of Japanese furniture making, or actually making in general, and like how things were made of a certain quality, of a certain size, of a certain material, and the ornamentation was not left out of it. And something that we've kind of suffered through modernity, I think, is that we've kind of lost our ornamentation as well. In a way, modernity has given us, white boxes. We live in these spaces. We kind of try to fill them up with things that we buy in the store. But ultimately, some of that personalization, customization that you would want as a human being, because we're all different, kind of is lost in that process. And I wanted to incorporate that into these pieces of furniture that I made. This is a kitchen table sort of bar that has the same kind of principles of what a kata, or like katana in this case, which is, kata means form in Japanese, but at the same time, katana is like the sword that we've seen in samurai movies, basically. In this case, the tanto is like a sword that has 2 blades on each side. So basically, it's very sharp on either end, and not just like the traditional Japanese sword. So it kind of got me into this idea that if you start to like push the limits of what the material can do by having some help with Grasshopper, in this case, you can make something look really thin, and kind of like to break that barrier of what something needs to look like to perform a certain expected, state. So in this case, I wrote a script that generally makes me very like capable of changing something on the fly and adapting the form of something to give me immediate input. So for example, like I'm pushing these levers like back and forth, and the sliders are allowing me to kind of like change the dimensions, how it looks, you know, the angles, the position of the apex of the bar, etc. As you can see, like this is actually the sheath. And the reason why it's kind of Japanese inspired is because it's supposed to look really thin from certain angles, but it actually has like a 3-inch thickness towards the core of the table and like only a 5/8 on the edges. And it kind of spans the length of it, and you can actually, two people can kind of sit on it, you know, without having a deflection. So these are the things that I could test without really having to build first. We have a very low number of workers available at all times. So I wanted to kind of like embody a lot of like what I'd learned over time into the work that I was doing. And to kind of push further, this is what it looks like. This is the sheath. One of the legs is detachable. It has a magnet. You can actually take the sheath, which is this little piece here, mount it on the wall, and then you can lift it up and kind of mount the whole thing, make it into like an actual waterfall island / bar against the wall. The table's legs, only one of them is kind of fused with the top, but the other one is pretty much free to do as it wants. Like you can actually go there, detach the magnet, and basically lift it up and kind of like turn it over and move it elsewhere, basically. So like it doesn't stay in that shape. And the whole idea is that it gives them the flexibility to change events, you know, they want to host at their party at place. This is something that I wanted to kind of preface a little bit before we delve into what we do together, which is this one-stop shop. This is one of my first projects where I not only did this kitchen table, I did the conference table, I did like their branding, I did the logo, which is like an LED sign that I had to learn how to do and all that kind of stuff through my journey. So it was a one-stop shop because now like that their space embodies some of the values that they want, and everything, including their sign logo, which changes colors to adapt to all the events that they want to promote. So another project that I kind of like, and what I do, I'd like to say that I sell stuff commercially online. And this is one of the things that has been one of the most successful that I've made. But ultimately delves back to something from the past, like I think 1650s, where campaign furniture was the go-to type of furniture if you went to a campaign of war, or like you traveled for a long time. Lord Byron, for example, had like a plethora of, you know, helpers to kind of carry furniture for him while he wrote like poetry, etc. And he passed through Albania, you know, like, which is my home country. So in that kind of sense, this project started out of like solving a problem from one of my clients, which they had a very small space. They wanted something flexible and they wanted to fit a lot of things in it. All the things that you generally like when the client says something, you're like, well, I don't know how I could put these all in the same container. And ultimately, I came up with this where it kind of creates something where it kind of folds completely and becomes closed like that. It's got wheels. It has the ability to unfold, and I've named it Hug and Knus, which is a Danish word for like hug, basically because of this embrace-like feeling that it kind of creates, you know, when you open it and close it. It features many different settings and placing of an organization so that you can serve different things, use it for different events and intimate gatherings as well. So this is, I want to end it here with like this project that I started a long time ago, but it has been revived recently, where it's the Normalite. It's based on the actual silhouette of the Marilyn Monroe famous photo of her dress, you know, over the vent. And even though that was the origin, it has taken it on its own life right now. So and this was part of like a research project that I did about lighting, where you take the shape of the project and you find ways to enhance or change the light pattern that it generates and how it casts itself on the wall and how it actually kind of shines everything else. So like this is all done for an independent study on rice at Rice University with we had Dr. Mojtaba Mavab basically to create some of this acoustic 2D, which is the software that you see in the middle, to create some of those diagrams and how light bounces into a ray tracing pattern. And then some of the smaller photos, I wish I could have found some more of that, but basically like how viewing it from certain angles also allows you to see different types of light patterns based on like that type of angle that you're viewing it at, because light and these fins kind of bounce light differently. And here we go. Like this is our kind of cumulative and collaboration kind of coming to a head, because we found ourselves wanting the same things and trying to work together to achieve bigger things. Now we're scaling up. So in a sense, you have, 2 people doing the work of 9 people, maybe through the help of CNCs.
So yeah, with the digital fabrication tools that I was utilizing, my kind of max capacity was the heaviest piece of plywood I could pick up. And now with 2 people, it increases that maybe by like 4-fold more than 2-fold, right?
Which is like a very simple but logistical problem.
Yes.
When you're working to build things, it's very humbling. So when you're designing on the computer, it feels like the worlds are, very close and far away at the same time, and you can do as you will. But ultimately, building something on your own, it's a humbling experience. At the same time, it's a learning experience. It never ends.
So with us kind of creating this partnership, we're able to take on larger projects that are, beyond maybe these smaller scale things that we're taking on. And we want to show off what one of those projects is. And the project is a breakfast kind of restaurant called Poached.
Yeah.
And what would you say their request was for the design?
I think it was the triangle again, the good, fast, and cheap. And ultimately, the idea of like trying to achieve all these 3 things in a commercial project while we also made money and we had a successful bid for this project, it required a lot of help. And I mean that in a sense that they did help with us, like they accommodated the fact that we can only operate in certain times. We have certain frame of time in which we can actually make things and bring them to the restaurant while the restaurant was still functioning. So we had to do all these things.
Yeah. So with that in mind, we also thought, well, how can we inject the things that we've been talking about? Like, where's the digital fabrication component? Where's like the thing that makes this like something else than just replacing the paneling in this place, redoing the furniture? And with that, we started to develop some patterns that we can maybe play with and lace on the objects and the graphic design. So we have an espresso cup, an egg, champagne glass for mimosas because it's a brunch place, bacon, and toast. And then we have a matrix here playing with ideas. So the sizing of the icons, which is based off the digital fabrication, instead of just operating in a bubble of, oh, I want the icon to be this shape. And then the different patterns we can play with.
What we're finding out was that this was a great strategy to see a lot of iterations quickly. It would be, and we can go back a little bit and talk about the pandemic, how it actually changed the way we communicate with one another and how being online has kind of been revamped. We rely on it a lot more. Him and I, even though we're like 20 minutes apart and we live, very close to each other, we are mostly talking online to one another. And this is the great thing about it, is that it gives us the freedom to do this communication without losing a lot of information in the process. Like, he would generate these patterns, and then I'd be like, okay, what if we did something like this? And he'd go back and pull like 10 more, and we would see it together and share the screen and all that kind of stuff. It's that was the fascinating thing about it. The other thing was that we also tried to help the restaurant kind of revitalize its brand, marketing, and kind of become a little bit more of a inclusive in its holistic like understanding of like the community, like who were the people, the clients that he wanted to have in his restaurant, what age group, like the kind of aesthetic that he really aspired to was the diner from like the 1950s, which everybody is so fond of, but ultimately had those aluminum lines, etc., the googie pieces of furniture and booths, and like the sort of the aviation age, of construction. So like we took that to heart a little bit and decided to kind of revamp the menu, did the logo, like all of that kind of stuff, like even give consulting and advice on like which kind of items are trending and doing all kinds of things that he would like to push forward towards clientele. And so far it's been great. So like he's very happy.
So as Pondush was developing like this logo that we see here, I was trying to figure out a way, how do we express this pattern, and how do we like put this in this restaurant without just being just a pattern? And with poached, I was thinking, it's like a poached egg where we see it, leaking out of here. So we took that to the wall system that they wanted to put on there, took the idea of the egg running down this wall, and then applied our pattern. So the pattern is laid out there, and then the scale of the icons is increased as it becomes lower on the wall. And then it's also playing with the where we're proposing some shelving and where the signage is going and some of the doors here. So as you go into this restaurant, you see like the egg coming down the wall, and see that.
So like the only other thing that we had to do was find out like how to make these things structural and how to install them in such a way that it was in a quick manner with a lot of people that are not necessarily experts at doing this kind of stuff, including construction. I personally have a background in construction and I've done work before manually, but the people that actually helped us are the owners of the restaurant and family, and they were kind of helping us kind of hang these things as if we built a fastening system.
So it was like, how do we leverage the digital fabrication of the pattern that we're doing to do other elements? So on the left here, we're showing that we created floating shelving just by putting holes in these panels and then cutting out more pieces that interlock with each other. And then we use a French cleat system just to hang them onto the wall. So the pieces were manufactured, they were assembled, they were finished, and then they were just brought to the site. The French cleats were put on the wall, and then it was.
And some of the work that kind of like the manual work, the detail that maybe in this case, like showcases how the CNC can be accurate to a degree, but then we wanted to achieve that level of professional finished look that, sometimes like you could see, we had to hide. I don't know if you can actually see it in this one, but like in these patterns, the depth of that cut, we were actually hiding certain fasteners to secure them to the wall as well. So they would not be seen into the surface. And this is what it looked like before. As you can tell, very outdated space that was supposed to be different types of functioning space. I think it was a sandwich shop at some point, and the bar that you see there did not exist before. So they placed like a makeshift one. This is we would find as standard in places like this when they're made ad hoc and at low cost. So we decided to kind of revamp that in many different ways. All the tables were made fresh, in the same material, which was 3/8 inch Baltic birch plywood. This is all 5/8. This is 5/8 layered, bar. Basically, we created that sandwich of vertical lines that you can see through.
And we created some sheathing based on that existing item. So you can see the bar, the structure of it, and the point of sale and all the tables is the same structure. We've just applied digitally fabricated tabletops, digitally fabricated slatting and walls to all these pieces.
And ultimately, like the idea was to keep the cost low while giving the maximum value and output. So this is the time lapse for this project. As you can see, there's at least 2 other people that are helping us install this. One was our co-worker, but also 2 that were part of the management and the ownership of the restaurant.
But in general, the entire project was installed in 2 days.
Yeah.
With one of those days being after they closed at 3 o'clock.
Yeah.
So because we were able to pre-manufacture, pre-finish everything, the major labor was installing the cleats and then just installing each item.
And as you can see the details, and like that's me serving some fake food from the kitchen to Chris. It also involved some of the decorative elements too that we accomplished, and what we wanted to kind of convey, and including the cups like falling off, pouring water and
and showing off the menus with different little digital fabricated pieces that then go into other pieces.
Right. So all of these are very one-stop shop. We kind of made that hangs there. They can move it, they can place it somewhere else if they want to, and kind of give them as much flexibility as they wanted. And what we'd like to do is work with local innovators that are context conscious, culturally immersed, and environmentally active. Like I feel like what Scott mentioned earlier, which had to do with like what we kind of expect to do as designers is to kind of change things. But ultimately, we are so often removed from the context of what we do through our, through the world that we live in, that we don't necessarily see the fruits of our labor right away. So there's not a lot of like gratification for a lot of young designers out there. And this is a good point to kind of stop and say that we provide a one-stop shop for these people, but also to kind of forge this community engagement and like, network and try to uplift the community as well. Because what we see in this case was that this actually resulted in real-time gains financially for them, not just like it was like an investment they could see the fruits of in like 2 months after operation. So this is kind of, what we're doing, but an ongoing project is also a set of like tables that are part of a project that was an architectural project that was done in Plymouth, Michigan, a renovation of a historical building, and all of the timbers that were left, like sort of like the 2-footers that were cut off when they brought in to replace them for the renovation, we take those and we kind of carve them up and we make consumer products themselves, tables and such. So yeah.
So yeah, thank you for listening, and we'll take any questions.
Yep. All right.
Anyone? All right. If not, thank you everyone for coming in person and online. You can stick around and chat for a little if you want, and we have some chips and salsa and some drinks, and thank you again.